Hello, everyone, and welcome to the 4th Academic Virtual Meetup sponsored by NIST, the National Institute of Statistical Sciences. The topic of today's meetup is applying for a statistics research grant. Our panelists today are 3 accomplished statisticians who have substantial experience in both obtaining grants and reviewing grant proposals, and are here to share some of their tips for grant success. I'm Mimi Kim from the Albert Einstein College of Medicine, and I'll be the moderator for this meetup. Here's the schedule for the next hour. After my brief introductory remarks, we will have presentations from Dr. Karen Messer from UC San Diego, Dr. Yehua Lee from UC Riverside, and Dr. Sujit Ghosh from NC State. Each speaker will talk for about 15 minutes, followed by 5 minutes for Q&A. We may also have some time for additional questions at the end of the meetup. A few words about the logistics. So Glenn Johnson and James Rosenberger, the director of NIST, are the hosts for this session. All attendees are view-only participants, but we encourage you all to submit questions anytime during the meetup for our panelists. To ask questions during the meetup, just click on the Q&A icon at the bottom of the Zoom window. Type in your question for the panelists and click enter, and we'll try to answer as many questions as time allows. So now I'd like to introduce our first presenter, Dr. Karen Messer, who's going to talk about what makes a compelling NIH grant proposal. Karen is, I'm going to give you introduce you. Karen is Professor and Chief of the Division of Biostatistics and Bioinformatics in the Department of Family and Preventive Medicine at UC San Diego Medical Center. Her methodologic interests include clinical trial designs, asymptotic properties of resampling-based estimators, and methods for the analysis of high-throughput data and genomics. She is currently chair of the NIH Biostatistical Methods and Research Design Study Section. Karen?
Thank you, and good morning or good afternoon, everyone. So I'm going to take a moment to bring up my slides. This will take me just a moment. Okay, there we go. So I hope you can see my slides now. Whoops, let me get to the beginning. Okay, so this is the somewhat grandiose title of my slides, What Makes a Compelling NIH Grant Proposal. And unfortunately, I'm not going to give you all the secrets to that large topic, but what I hope to do is direct your attention to where you should look for resources to help you make a better grant proposal. Let's see, why am I not able to advance this? Okay, so let me give you a little bit of background. I am the chair of the BMRD study section, but of course here in this role, I'm commenting completely as an individual. So these are my personal comments from my experience writing grants and reviewing grants. I'm here at UC San Diego in the Division of Biostatistics and Bioinformatics, and we are situated in UCSD's medical school. We are, like many biostatistics groups, we are a combination of state funding and grant funded. So most of us, in fact, all of us, have substantial grant funding. We're responsible for a large portion of our salaries, as most biostatistics groups are. And so that means that I have participated in many grant submissions, both as co-investigator and as principal investigator. And here, note that I say I participated in many successful and even more unsuccessful NIH grant applications. So that's one of the lessons of what I want to convey, is that getting successful funding, obtaining funding, is a percentages game. And we all know how to compute probabilities. The more times you try, the more likely you are to eventually succeed. So when you apply for funding, it's best to just have the attitude that it takes multiple tries. and not be too disappointed when you don't get funding on any particular occasion. I've also participated in many NIH study sections. So I have read many grant applications. And I've been on both the biostatistical methods study section and many other kinds of study sections. So I hope to share some of that perspective with you. And I suspect we have a diverse audience out there this morning or this afternoon. So I encourage your questions because I don't know if my comments are going to be directed at the right level. Some of you know more about NIH grant, the NIH grant process than others. I thought it would be best to just outline the basic structure of the NIH funding process. And the first point is that it's a bipartite structure. Review is usually separate from, well, is separate from the funding decisions. And in fact, they're carried out in two entirely separate centers within the National Institutes of Health. There's a very large Center for Scientific Review, which runs, I believe, thousands of study sections every year, or it's at least close to 1,000. There are just many study sections going on all the time. This is where grants are reviewed and scored. And BMRD, as we call it, is such a thing. It's a study section. So that's where your scientific peers will be sitting around, reading the grant and discussing the grant. And it's a very formalized procedure for review. The Center for Scientific Review has put a lot of effort into investigating what makes for a fair and thorough review. And so it's a very formal procedure. At the end of that procedure, your grant receives a score, or sometimes it doesn't receive a score. There are lots of details like that that one needs to learn when you get into the NIH process. The top half of grants are actually scored, and the bottom half of grants, you would receive written, sorry, I said that wrong. The top half of grants are discussed. The bottom half of grants, you'll receive a written commentary and a written score, but not the results of a discussion. So grants are scored as to their relative merit in study section. That's the first part of the bipartite funding decision. The funding decision is completely separate. It's made by an institute or center that is disease focused. So the review is focused on the technical area, and that's why we have a statistics section comprised of our peers who are statisticians or have related appropriate expertise. Whereas the funding decision is in an institute or center that is disease-based. For example, the National Cancer Institute or the National Institute on Aging. And there, your point of contact is a program officer who's focused in the area of application. One tip is that it's very important to talk to your program officer to make sure that your proposal is in an area that they find important. And you should talk to your program officer before you put in the grant, at the time when you have an idea. You should write up a very short synopsis of your idea, email it to the program officer, and see if that's of interest to them. Okay. And then about the funding. Each institute has its own pay line. So some institutes are funding, and that varies from year to year depending on the level of funding. That's the level at which they will be seriously considering your grant for funding. For some, it might be the top 15% or the top 12% or the top 7%. Pay lines are extremely stringent. So that's the interface between the score and the institute. The score determines where your grant sits among its peers, its percentile. Are you at the top 10% or the top 12%? That information goes to the institute, and then the institute prioritizes those very top grants for funding according to their priorities. So when you write a grant, you have those two audiences in mind. One is your technical statistical peers in the study section, and the other is the program officer and the other interested parties in the institute. I'd like to point out that early stage or new investigator PIs have a funding advantage. Those grants are percentiled separately, scored separately, and pay lines are often more generous for those grants. So those of you who have not yet had an NIH R01 have a considerable advantage, and that's a very nice thing. It helps you get your first R01. And then finally, I'd like to point out that NIH puts out specific RFAs and PAs. That's, what do those stand for? It's a very jargon-heavy discipline. So program announcements and requests for applications. And so they might be calls for specific areas of interest to a particular institute. However, you should also know that most grant applications are to the parent program announcement, which means they're not in response to a specific call for applications. They are investigator-initiated ideas where someone has said to a program officer, would this potentially be of interest to you? And having received some encouragement, they're sent in as just a general grant application. So you're not constrained to respond to an RFA. I see that I'm going a little bit slowly. Let me speed up. I want to leave time for questions. NIH has beautiful resources to learn about what makes a good grant. So I've listed some of them here. The Center for Scientific Review, I would highly recommend that you go to their For Applicants page and just explore the extensive resources there. They have videos, they have a mock study section that's been posted. That can help you learn about review criteria and common problems with grants. There's a more specialized page called StatFund that's at the National Cancer Institute that has some specific resources for statisticians. Some of the information there may be a little bit out of date and it may be focused more towards cancer, but nonetheless, it's a good introduction. Your center's website, whoops, there's a typo, I'll correct that. Your center's website is also a very good resource. So if you're working in Alzheimer's, go to the National Institute on Aging website and look for the Alzheimer's, the program officer that's focused on Alzheimer's. My next piece of advice is learn the specifics about review criteria because it is a formal process and reviewers have strong guidance about what they should look for. I've given you the scoring rubric here for NIH that all study sections use. The most important thing is overall impact. That's the likelihood for a project to exert a sustained, powerful influence on the research field involved. And then there are criterion scores, the significance of the project, the team of investigators, how innovative it is, whether the approach is rigorous and considers all possible alternatives, etc. Each of those criterion scores has review criteria associated with it. So you should educate yourself about that. And again, there are resources on the NIH website that describe those criterion scores and what reviewers look for. The best way to learn about the review process is to be a reviewer. I assume that many of you are early career, so are perhaps assistant professors, have not yet had an NIH grant. NIH has a special program for early career reviewers. Normally, early career reviewers are not invited to serve on study section, but you can register your interest at this website and apply to be in the early career reviewer program. Many study sections have a designated one slot for an early reviewer at each review cycle. And this is really the best way to learn about NIH review. There's nothing like reading a poorly written grant to help you understand how to write a better grant. Okay, I'd like to close my remarks in the next minute with just some personal comments, and then I'd be very happy to take questions. So please understand that each reviewer is going to read about 9 or 10 grants, and in BMRD, for example, these are often fairly technical. They take a lot of effort. Reviewers typically spend perhaps 2 days or sometimes more reading each grant and digesting it and trying to understand the context. So that's a lot of material to read. Reviewers will not all be expert in your area. It's likely that at least one reviewer will be, but several others may not be. And then the general membership of the study section, which might be 30 people, will be broad. So you have to speak to the general statistical audience. And you also have to speak to whatever disease area you're talking about. There's my phone telling me I'm out of time. So the point here is, make it easy for reviewers to grasp your ideas, and especially the specific impact of what you have proposed to do. That's the key. Your proposal has to advance the science in whatever area you're working. And it has to be impactful and important. So be clear, be concise. We have a lot of reading to do. We don't want to read extra stuff. Situate the work in the literature. This is a common problem where you come up with the greatest things in sliced bread, but maybe there are also other bread slicers out there, and you have to tell us exactly what new innovation you have in relation to the rest of the scientific literature. Please tell us why it is important, and it should be specific. Demonstrate the real-world impact. So an NIH grant addresses biomedical science or public health. The domain area that you're working in, your work has to demonstrate that you will impact biomedical science or public health. The application must be convincing. So when I say application here, I don't mean the grant application, I mean the statistical application. So the application of what you're proposing in the scientific world should be convincing. Demonstration projects or toy applications usually are not scored highly. Your team should include scientists working in the domain, and you should be addressing a problem that they find to be important. And then lastly, convey your statistical ideas with adequate technical detail so that they're credible and convincing, but make the ideas accessible. Make it easy for the reader to understand the main idea of what you're proposing. Have others read and comment on your application, revise, and be persistent. Okay, I'll end there. I'll just say good luck, have fun, learn a lot. By the time you've written a grant, usually you have learned a lot, you've sharpened your ideas, you've helped advance your own work, and that's often a big benefit. Okay, I will quit there and take questions if there are any, and if there's time.
So thank you, Karen, for sharing your valuable words of wisdom. We do have one question. What are the funding agencies for biostatistics focused grant applications or data grants? Yeah.
Okay, so that's a very general question, and that's an important question. NIH are the National Institutes of Health, and so they are focused on public health, usually in specific disease areas, but sometimes in specific areas of biomedical research like genomic research. They don't fund statistics for the sake of statistics. They fund statistics for the sake of advancing science. So to have a strong application at NIH, you have to have, it has to be a collaborative project where you have a strong area, a strong domain area that you're working in. For example, in cancer or in HIV or in genomic research in some area of biomedical science.
So does that mean that an NIH grant application would look stronger if you include a clinician or a lab scientist from that disease area on the grant?
Definitely, definitely. And one common criticism is that the clinical or the collaborator or the domain scientist might not be deeply involved in the research project. So it's important to be working in an area where you are advancing science, where your statistical efforts are working hand in hand with scientific efforts. It's important to demonstrate that real world impact.
So we have a question. What should we do if the program officer never replies to an email about your grant?
Program officers are very, very busy, and they get lots and lots of emails. That's a difficult one. I've never had someone completely not respond. Maybe go to a different program officer, maybe try to find a related program where that might be more interested in what you're working in. I guess it's it is a de facto response of non-interest.
And we have time for one more question. And I think this is one that a lot of people might be also interested in asking. How theoretical does the stat proposal need to be for the BMRD study section? This person was advised to avoid the BMRD for combined methods domain projects that are not theoretical.
Well, I think that that's something that BMRD has gone back and forth on a little bit over the years. There does have to be statistical innovation. The innovation doesn't have to be in the purely statistical literature. In other words, you don't have to invent a completely new method. You do have to be bringing something new either to the domain of application. For example, taking methods that have been developed in pure statistics and being innovative in your application in a way that's impactful and would drive the science forward. So the statistical innovation has to be at the heart of your grant, but it doesn't have to be purely methodological innovation. Nonetheless, if the level of statistical innovation is low and the impact and novelty is all in the domain area of application, for example, in a specific disease area, then you're better off focusing the grant towards the science and having it go to a disease-focused study section.
Okay, thank you, Karen. So I think we need to move on to our next speaker, Dr. Yehua Li, who's going to talk about applying for a statistics research grant from the National Science Foundation. Yehua is professor in the Department of Statistics at UC Riverside. His research interests include non-parametric and semi-parametric statistical methods, functional data analysis, spatial statistics, time series, measurement error models, and mixture models. He has been the principal investigator of grants from the NSF and NIH and was a recipient of a NSF Career Award in 2012. He has also participated on multiple grant proposal review panels for national and international funding agencies. Yehua?
Oh, thank you, Mimi. Thank you so much for inviting me and having me involved. So Mimi already talked about my first slide. So a little bit about myself. Again, I have been in the workforce since 2006, has been 13 years. Just like Karen, most of the time you read a lot of proposals, but there's only a limited number of success. I listed a few of my success proposals. There are way more unsuccessful proposals. So you have just to be persistent. So there's a disclaimer here. I'm not officially associated with NSF. I wish maybe should have invited someone like an NSF program director, like an equivalent to Karen's role, but here I am. So all I can do is to share some of my personal experience, and the data, hopefully that will be helpful to some of the junior faculty, and some of the data I present are from public information. Okay, so why do we need to write an NSF proposal? The statistical program at NSF and the BRMID study session from NIH are the two biggest funding agencies that fund the statistical methodology research. There are other agencies and programs that support statistic research, but you will need to compete with computer scientists, mathematicians, and other researchers who believe they know statistics. So there's a lot of competition. Some other agencies and the industry funds take years of networking. For example, Bureau of Labor Statistics. NIH grants, like Karen said, require real biological medical applications. The goal is to advance medical science and improve health. So a lot of the time, your research aim need to be aligned with these goals, and you need to build a research team involve doctors a lot of times. For junior faculty, very often such connection or network does not yet exist. So that's why NSF is still the most viable option here. And also for more fundamental statistical research, especially for theoretical research, NSF still provides the biggest opportunity out there. So maybe it's helpful to understand the NSF structure a little bit. From the director down, there are 7 directorates and multiple offices. The funding research programs are usually organized in one of these directories. So as you can see, there are the directories of biological science, Directorate of Computer and Information Science, and so on and so forth. But the statistical program is resided in the Directorate of Mathematical and Physical Science. There are statistical opportunities across other directorates, but my main focus here today is going to be the statistical program under MPS. Okay, so we're going to look a little bit closer to MPS, Directorate of Mathematical and Physical Sciences. There are 5 divisions, and you can see chemistry, material research, and so on and so forth. One of them is the Division of Mathematical Sciences, the DMS. Statistical program is under the Division of Mathematical Science, but parallel to the statistical program, there are other branches of mathematics, algebra, analysis, and so on and so forth. As you can see, the point of this is NSF is a big organization providing funding opportunities covering all aspects, all areas of science and engineering. About the funding rate seems to be a little bit higher than NIH. Within the MPS, you can see the overall, the cross funding rate in 2019 is about 27%. There are these divisions, and Division of Mathematical Science is somewhere in between. It's about 26%, but there are way more proposal than the other divisions. So the NSF has a budget of $7 billion, which is a lot, provides 24% of all federal funds for scientific research. So the budget is lower than NIH, but NIH also support infrastructure. In terms of research funding, it's about perhaps the same, or NSF is slightly lower. As I said, NSF covers so many areas, so the pie has been cut into smaller pieces. Okay, so for statistical program, an NSF grant normally means 2 months of summer salary for junior faculty, or 1 month summer salary for senior faculty, because salary level is higher for senior faculty. There could be some travel money budget for computation, for example, membership for your high performance cluster computer center. A standard award is usually a 3-year grant. The dollar amount depends on your salary level, obviously. Junior faculty rarely get support for graduate students or postdocs. But the good news is your proposal is judged by its merit. It's not based on your budget. Proposing a smaller budget will not increase your chance. So my advice is just propose what you need. And if your grant gets funded, the program officer will work with you to revise your budget. So what does an NSF grant mean for junior faculty? This is to help you to get to the right mindset. So first of all, summer salary. Most of us are on a 9-month salary basis, so the extra support is welcome. The privilege of an NSF grant means national recognition, and this is the time to prove that your research program has not only intellectual merits, but also broader impacts on science and society. There's also a strong correlation between grant and promotion and tenure. Over these years, I have seen people with an NSF grant, but still get tenure denied in some of the elite schools. But for most of us, especially in public university, there's perhaps a 90% strong correlation between an NSF grant and the promotion. So it's almost a guarantee. And also, just like in NIH, the good news is NSF offer new researcher incentive. They do consider new researcher as a factor, and they will not compare your proposal directly to a well-established researcher like a full professor from Stanford. Okay, so what does an NSF proposal include? The most important, well, the major part of the proposal is the project description, which is 15 pages long. I would advise to use up all the page limit. I would use single spacing, the smallest font allowed, 11, maybe font 11, and elaborate all the details, give as much detail as I can, try to be convincing. So if you don't use the page limit, sometimes it shows you're not serious enough and you don't have enough to say. The project summary has a 1-page limit, which sum up the intellectual merits and the broader impacts, perhaps the single most important page of your proposal, and we'll touch that later. BioSketch is limited to 2 pages, and you could include references, other supporting documents like current and pending support, facility equipment, so on and so forth. The DMS statistical program is a regular annual solicitation, so you can submit only once a year. This year is early December, and don't wait till the last minute to submit your proposal because FastLane might be busy. Start at least 1 month before the deadline. This is only for writing. If you're junior faculty, if this is your first proposal, maybe give yourself 2 months. I will talk about this later, rough ideas and plans should be in your heart long before you start writing. So you, just like Karen said, you need to keep on writing and revise your proposal. So for this month, you should devote every effort into grant writing. Ask your mentor or colleague to proofread your proofread your proposal, and ask for comments. At the meantime, you have to work with your secretaries to work on the budget justification. Your college should have a designated personnel to help you to put the proposal on fast lane. You can revise your proposal to the last minute, but the other supporting material should be submitted, should be uploaded beforehand. Okay. So regarding the content of your proposal, the advice I received was use the proposal as an opportunity to organize your thoughts and plan for your career. So I thought that, when I was junior faculty, this is perhaps the most important advice I got. So you should write down the ideas you came across in your everyday research. When you attend a seminar, when you review a paper, when you do your research, when you read literature, ideas will come across, and there might be extensions to your existing paper, and you don't have time to work on these ideas right away. Before you forget them, write them down somewhere. And when you get to the writing of your proposal, this is the time to recycle and organize your ideas into a common theme. When you start writing, you should identify a few problems under a common theme that you want to investigate. Keep in mind, the work needs to be worth 3 years of effort. For my personal experience, I would identify 3 big problems as my objectives, and there might be numerous topics on related statistical issues. Software development is usually an important object to achieve broader impacts, and there can be education component in your proposal. NSF list training future workforce as one of their mission. So that could be part of your proposal and the broader impacts. So you should think along the line of the 2 NSF Merit Review Criteria. Those are the intellectual merit and the broader impacts. These are summarized in that 1 page. Your reviewer are trying to justify why NSF should spend taxpayer money to support your research along these lines. So you should help them to make their job easier. So you need to clearly state how important the proposed activity to advance knowledge in your own field and across other scientific field. And also you should clearly state your broader impacts like promoting teaching, training, broaden participation of underrepresented groups, so on and so forth. You should clearly state the benefits of your proposed activity to the whole society. In terms of writing style, I would suggest you borrow funded proposals as example from your colleagues, major professor, or friends. Clearly define the problem, why the problem is worth investigating, and how the existing method fell short addressing these issues and what you propose to do. Show your plan are reasonable and likely to succeed. You need to show how you have thoroughly thought about all the issues and present the preliminary results. And but you should show there's still plenty of work to do for the next 3 years. Sometimes it's also helpful to provide a timetable to carry out the plans. Also, be a part of an NSF review team. Try to volunteer to serve on the NSF proposed review panel so that you get a chance to learn from the successful proposals. Okay. I think I'm running out of time. So say a few words about the career award. The career program offers the most prestigious award for earlier career faculty. Usually the budget is $400,000 for 5 years, so higher prestige, more money, longer supporting period. And the best of all, only pre-tenure junior faculty are eligible, so you are only competing with your peers. It's not a single PI proposal, but you can include a couple of collaboration letters from your senior collaborators. This is optional, but the proposal needs to be your own idea. Your collaborator, the collaboration letter only confirm your collaborator's intention to collaborate. It's not a recommendation letter, but it might add to your credibility that someone are willing to collaborate with you and your research plan is likely to succeed. And also you need a good education plan. This has to be a component in your career grant. Everybody is trying to do course development, student advising, and you want to be creative, but also genuine. You can only submit one career proposal in any given year, but you have 3 chances before tenure. I got my career award the 2nd time, which is also on my 6th year. And I was lucky some of the more qualified people either get funded the previous year or get promoted are no longer eligible. So keep on trying, and sometimes you could be lucky, right? So you can start from your 1st year and revise your proposal based on feedback and submit again the next year. The deadline is in the middle of July, and you should check the solicitation. If you start early, you can submit a career grant, and you can revise it and submit a revised proposal to a regular statistical solicitation. If funded in one program, you can always withdraw from the other. There's also a career webinar on the NSF website you can look into for more information. So lastly, don't give up, try again. As you can see, the competition is fierce. The funding rate is kind of low. Most people are trying to present their best work. So only 10% of proposals are not really not careful enough. Most people are trying their best. Still, only about 25% of proposals get funded. The top proposals are ranked as must fund. Those are truly outstanding. So if you have an opportunity to serve on the panel, try to learn from these proposals. Some of the bottom ones are ranked not fundable. Those are usually flawed. Proposals in these categories usually get the result very early. They know the result almost right away. Most other proposals are ranked in the middle, fund if possible. Those will remain in the queue, and the program officer will work through, he or she will come up with ranking, work through these proposals, work with each PI and revise their budget. So one of my proposals waited all the way until the summer of next year. It's all way past the starting date of the project, and I was lucky to get that fund, get that grant, and had to back pay to my summer salary. But as long as you haven't been turned down, that means you still have opportunity, you are still in the queue. So once the feedback come back, you should read the comments carefully. If you're not funded, try to address these comments very carefully and submit the next time. Try a different data example, give more convincing preliminary results, sometimes even go to a different program. So try to branch out. There are other NSF programs support statistical research. For example, the DMS, NIGMS joint program, which is a joint program between DMS within NSF and the NIH the National Institute of General Medical Sciences at NIH. They support fundamental research in mathematical and statistics necessary to answer questions in biological and biomedical sciences. There's also the MMS program in the Directorate for Social, Behavior, and Economic Sciences. If you work on bioinformatics, you can also try the Rule of Life program in DBI. They might even provide higher, higher support. The standard statistic grant usually give you 100 or 200K, but DBI sometimes give you bigger grants, sometimes like $500,000 to $1 million. And for some of our mid-career colleagues here, we have lost the new research incentive. It's time to branch out and seek out more collaborative work and maybe even look into opportunities from NIH and other agencies. So writing a proposal can be stressful, can also be very rewarding. Even if not funded, this is a good opportunity to organize your thoughts and plan for your career. Thank you.
Thanks, Yehua. So we have a number of questions. Unfortunately, we only have time to field about one or two, and then the others we're going to try to respond to you individually by email.
Okay.
One question is, does NSF have a training grant for postdocs similar to a K-99 from the NIH?
I'm not familiar with K-99 in NIH, but I think they do have funding opportunity for postdocs, but that I haven't tried.
And are there any online examples of successful NSF grant proposals that people could use as a guide for their own application?
I'm not aware, but most of the time you find examples, good examples from your colleague or your advisor or friends. You can also ask for ask your mentor.
Okay, so in the interest of time, we need to move on to our third and final speaker, Dr. Sujit Ghosh, who's going to talk about some other funding opportunities for statisticians and grant resources available from the ASA. So Sujit is Professor of Statistics at NC State University. He conducts research in biomedical and environmental sciences and other areas. He has served as a statistical investigator and consultant for over 40 different research projects funded by various leading private industries and federal agencies, including the EPA, CDC, NIH, and NSF. He's also served as a program director in the Division of Mathematical Sciences at NSF and is currently co-chair of the ASA Committee on Funded Research. Sujit?
Thank you very much, Mimi, for the kind introduction. Excuse me. So I think by now you know a lot more about NSF and NIH, and I think I would like to focus on what are the other alternative resources that you might tap into when you are considering submitting proposals for funding opportunities. And as Mimi pointed out, currently I'm serving as the co-chair of the ASA's Committee on Funded Research, where I think Karen has also served before. So what is ASA-CFR? I think this is a great resource. If you have not been to this site or resources, I think you'll find this very, very useful. What this committee does is to facilitate the communication between the statistical community and funding organizations. And when I mentioned funding organizations, it did not be just NSF, NIH, but many others, which I'm going to talk about in a bit. And it also collects information from state of the funding of statistics and provide reports to ASA board as needed. And a person that works at ASA office is Steve Pearson, who you can get in touch if you have some issues that you want to bring into this committee. And in particular, the website that actually has a lot of resources appears at the last bullet point on this slide. And I think NIS is going to make this available online, and these links are clickable and you can check this out. But I'm going to give a short glimpse of what are the resources that are currently available. With the interest of time, I'm just going to focus on some of the resources that are not NIH or NSF, because I know Karen and Yahoo has done a great job of describing some of those. So one thing that ASA CFR that we started to do this year is to launch webinars. And so far there has been 3 webinars, and there are much more coming this year and the next. For example, Mark Award from Purdue talked about building undergraduate programs. So for juniors, this may not be useful, but for mid-career, I mean, there are other funding proposals which are training purposes, and Mark talked about that. The good thing about these webinars are that the slides are available and the video recordings are also available, so you can look at that or listen to that at your own convenient time. In particular, we also had a program officer from NIH, Elizabeth Genexi, who talked about behavioral and social sciences research in health, and that was very useful because they just launched a new program sometime last October, and it is still in process. And also Anna Maria Staiku, one of my colleagues at NC State, talked about NSF career proposal, like Yahoo mentioned, and you will find some more details specifically for the career proposal. She also talked about what not to do, and she also got that in her second try. And so she also discussed there what are the things that were not found useful and how she rectified. So you might find the recording and the slides quite useful. So this is another resources that you can get into to get more information. So now let me talk about some other resources. So of course we know of NSF and NIH. These are definitely the prime sources for funding, but there are many that we are trying to bring to a community through this Committee of Funded Research Resources, and all these things link you will find on that website that I mentioned a couple of slides ago. So there are foundation grants that are not that popularly known, but you might want to get into that. The submission policies are not always same as NIH or NSF, and sometimes they don't even need all 15 pages. So you need to spend some time figuring out what are the things that you need to do. And because of the interest of time, I'm not going to get into details of any one of those. But as I said, on the resource page for ASA-CFR, you can click some of this link and find out what they are. And also there are for-profit companies, although the scopes are a bit limited in the sense that these companies have some kind of research programs where you will find that you might want to involve as a research collaborator, or sometimes your student can be involved as a research in a research project. For example, the Novartis has presidential postdoctoral program, and there are many others. So what I'm trying to convey is that, of course, you should try the NSF and NIH grant options or funding proposals, but there are other options too. And these are not restricted to only folks who are in their mid-career, but even early career as well. But I would recommend that you start trying some of this when you are at your mid-career than early career, because as Yahoo pointed out, if you're trying to apply for NSF career, then you would you have only few years to apply for that. And then finally, I'll conclude with some of my own tips. And I served at NSF as a program officer back almost 6 or 5 years ago. And as I think Karen, so this is kind of repeating, so I'm not going to go through all of the bullet points. But I found that majority of the proposals fail because the contribution to the field is often deemed incremental, and you might see that when you get the review back. And this is a tricky thing: what is incremental, what is not. And for that, the best thing is to actually get some feedback from some of the senior or seasoned faculty members who have been more successful in getting grants. As a former PD, I mean, at NSF, sometimes it really doesn't matter how good the idea is if the reviewers can't understand it. So that's another thing. I mean, it can be technical, especially for NSF, but at the same time, it should not look like a list of theorems and proof. You are writing a proposal and not a finished project. So the best idea that I think Yahoo and Karen also pointed out, beg, bribe, whatever you want to do, get some feedback from your colleagues. And what are the things that you want to think about writing a proposal? Well, first of all, it's not a technical paper, and nor it is a murder mystery that you keep building, and then at the last page you say, well, this is my idea. That's not going to cut it. And so it is a balancing act of how much to give details, and it should not look like a finished project, because if you write a project where everything has been done, then why someone would be funding your project if everything is done? And yes, I also agree with the previous two speakers that you try to be volunteer as a reviewer. I saw one question during your talk, how you can be a reviewer at NSF. So when I was there, I mean, the best thing is to contact one of the program officers. Their phone numbers or contact numbers are always available online. You can just contact them and say that you want to be want to serve as a reviewer, and she or he might ask you to send your CV, and that is kind of kept there. And once a proposal comes which matches your expertise, they might contact you. So that's one way to do that. And when I was in NSF, I saw that people were doing that, and they were very useful, especially to program officers, because in a way you are helping them to let them know that what expertise you have if you were selected as a reviewer. So I know we are running out of time. So I left some useful links that you might find useful. For example, the current deadlines at NSF, this gets automatically updated if you click that link. So there are some excellent podcasts at NIH, and also one article that ASSCFR published, Funding Opportunities, Better Statistical Participation is Needed Across Collaborative Science. I know Karen was also one of the co-author on this particular article, and you might find this very, very useful to read. With that note, I think I'll stop and take questions if we have any. Thank you.
Thank you, Sujit, for all that valuable information. If I could ask all of the panelists now to turn on their mics and their videos for general Q&A. So one question is, what things did you learn from your unsuccessful grant proposals?
Karen, Yahoo, you want to go or you want me to answer?
Well, having had more unsuccessful than successful proposals, it's very valuable to get feedback on an unsuccessful proposal. You often get pointers from experts in the field to research that you hadn't considered, or aspects of your research that you hadn't considered, or evaluations of the direction you're going in. It's like getting a critical review of a paper. It's painful, but it's often very, very instructive.
Right. So sometimes the broader impact are not convincing. Sometimes you can find a better example to motivate your statistical methods, and just help you to think deeper into your proposal will need to be addressed. And there might be some literature that you didn't, you missed, and the reviewer might point it out, and you can learn a lot from that, and try to discuss what is new, what is different from your proposed approach to what's existing in the literature. What things you can offer.
And what's the best way to prove intellectual merit in a proposal?
Well, I think it's probably better to give some preliminary example. So do some kind of simulation or comparison to show this is a problem, have its own characteristic. Some of the existing methods may not fully address all the problems in this problem. And first of all, it should be an important problem, needs to be addressed, and the existing methods are not addressing all the statistical issues, and what I'm proposing can offer more, and try to stress the importance.
Yeah, I'll also add one thing is that sometimes in a proposal, a lot of people are trying to squeeze in a lot of information because of the 15-page limit. But sometimes very good graphics that illustrates your idea is far more useful than writing hundreds and hundreds of words. And that I have seen that because if you think about it, the reviewers have at least 9 or 10 proposals to read. And sometimes you are really helping them by having a good graphics. And I'll tell one experience for my own thing. I mean, I wrote one, it was unsuccessful, and that was kind of the feedback I got. And then I included a graphics to just a very simple example that Yahoo said, based on a simulation. Here is a thing that I can see clearly why the other methods are not working, and this is my idea. I don't know because of that or not, but that time the proposal was funded. So a good graphics with an example that shows the idea is far more useful than thousands of words.
And I would add briefly that for NIH grants, you have 2 audiences. You have the technical statistical audience, and you have the domain audience back at the disease-related center. So echoing what Sujit and Yewa have said, you have to communicate, and you have to communicate on several levels. You have to convey the importance of your ideas to non-specialists, as well as specialist but very tired reviewers.
So we're at the top of our hour, so we need to conclude our meetup. There were a few questions that we unfortunately couldn't get to, and again, the panelists will try to respond to those directly via email. I want to thank again our 3 speakers, Karen, Yewa, and Sujit, for being on our panel today. They are all extremely busy people, so I'm so grateful to you for volunteering your time for this meetup. I also want to thank Ezra Kurum, Kevin Lee, and other members of the NIST Affiliates Committee for helping to organize this event. Following this meetup, you should be receiving via email a link to a really brief survey so we can get your feedback and ideas for future meetups. The recording from this event, as well as the slides, will be posted on the NIST website in a few days for everyone to view. So hope you'll participate in future NIST activities, and finally, have a happy and safe Halloween, everyone. Bye-bye.
Bye, thank you.
Thank you, bye-bye.
Bye.